Okay, good evening all and welcome again. So we are discussing on the GIS, the gas insulated switchgear substation. So yesterday we started this topic. So let us quickly review what we have discussed yesterday and then after we'll start the today topic. So what we discussed yesterday, that first of all we discussed that what is the type of the substation. We discussed the type of the substation, right? Type of the substations, and we discussed that substation could be three type. It could be out like indoor, it could be outdoor, and it could be the combination of indoor and outdoor, or the combination of GIS and AIS, which is called as the hybrid type substation. So for the indoor, it could be two type of the installations. Further, from voltage LT 415 voltage till 33 kilo voltage, we can go with the uh, switchboard type, metal enclosed switchboard type. So I'm putting just switchboard type. And when the voltage level increasing, in that case, we can go with the GIS type. Now this switchboard type, again, we can divide into two type further. If we take this like type of the switchboard, it could be AIS type and it could be further GIS type switchboard, GIS type switchboard. So the substation site or any project site where the space is limited, in that case, we go with the GIS type switchboard. The AIS type switchboard take generally for one panel, it take approximately 800 millimeter to 1 meter width, 1 meter width, the panel width. I'm talking about this panel width. So this much. So when the space is limited and we wanted to reduce the panel width, in that case we can go with the GIS type panel as well. That also is available and that also we use in the project. And this panel width is less compared to AIS switchboard. It could be in the range of 400 to 600, in that range. It could be in the range of 600 millimeter or max to max. Means this is in the range of 400 to 600 millimeter. It could vary manufacturer to manufacturer. This is up to 33 kilo voltage. But when the voltage level increasing beyond 33 kilo voltage, in that case, we go with the GIS and then we go with the module type, GIS module type substations. This is for the indoor, and then we discuss outdoor, which is called as the AIS. And we discussed yesterday also that this GIS module, again, it in the outdoor, again, if we take, again, there could be two type. It could be conventional outdoor AIS type subsystems, and the outdoor GIS is also available. Outdoor GIS is also available. That also we have discussed yesterday. And we discussed that sometimes in the project when we wanted to minimize or avoid the building civil cost, uh, because when we are making the building to place the GIS model indoor, so when we wanted to minimize this, sometimes some companies, some project take outdoor GIS. So in that case, the building is not required. So civil cost is saved here. So when we are purchasing, as a design engineer, when we are purchasing the GIS, we have to inform manufacturer that whether this GIS we are taking indoor type or outdoor type. Because the module constructions, the module ingress protection IP class is changing from indoor to outdoor. So this clearly we have to write, even though we are putting the GIS, but again we have to write GIS indoor installations, because GIS could be outdoor as well. So outdoor again, it could be AIS or it could be outdoor GIS also, it is possible. Now coming to the hybrid type, so it is the combination of AIS and few equipment we are combining together and we are taking hybrid switchgear. So that it is the combination of AIS plus GIS. Are few equipment we are combining together. So it is AIS, but few equipment like the circuit breaker and disconnectors we are combining both together. So it is called as the disconnecting circuit breaker, like that. This equipment could be called like that. So this is all the example of the hybrid type subsystem. So yesterday we have taken this point. This point we discussed yesterday, right? This is our point number 1 of the study discussions. Thereafter, what we discuss. So AIS we have discussed. So now we discussed that when we start any electrical project construction, so we have to prepare the drawings and we have to prepare the calculations, drawing and calculations, and we have taken the reference of the list of the drawing and calculations. In that, the single line diagram is the first drawing that we have to prepare. SLD is the first drawing that we need to prepare as a design engineer. So SLD preparations will change based on the type of the substation. So we have discussed SLD for the AIS in the module number 4, right? Now we are discussing SLD preparations for the GIS type substations. So we have taken this GIS type substations and their SLD. So now this GIS we have taken in the detail, taking not only the SLD, but we are starting first the introduction of the GIS, the construction of the GIS, and then as GIS SLD, and then we will discuss about the GIS layout preparation as well. So this is what we started yesterday, right? And then we discuss about this type of the substation based on the voltage level that we have discussed yesterday. We discuss yesterday about the history of the GIS, that when and where this GIS substation developed. So this we discussed yesterday, right? And we discussed that in some specifications it is written as gas insulated substation, but the correct name is gas insulated switchgear. So whenever we are talking about the GIS, please make sure it is gas insulated switchgear, not the gas insulated substations, right? So we discuss yesterday the correct name for the GIS, and then what we discuss, we discuss that in GIS what we are taking, and we discuss the difference between AIS and GIS, right? We discuss a study the difference between AIS and the GIS. So in the AIS, the equipment is air insulated switchgear. Between the equipment, air work as an insulating medium. But when it comes to the GIS, the gas work as an insulating medium. So we discussed that what is GIS. So GIS is a compact assembly of the switchgear, or we can say compact assembly of the equipment. Which equipment, like the disconnector breaker, CTBT, all the equipment that we use in the substation. So that equipment compact assembly of the equipment, and placed are installed in a metal enclosed housing, and which metal we take. Yesterday also we have discussed this metal we take aluminum alloy, right? So compact assembly of equipment placed in metal enclosed, or we can say aluminum alloy enclosed housing, and filled with the SF6 gas. Filled with SF6 gas. So this gas also have the pressure. This gas also we have the pressure. It is compressed gas. So on which pressure we compress, this also we have discussed. And we discussed that what should be the guaranteed leakage rate of the SF6 gas as well. And in order to inform operator that if the gas pressure is decreasing, so we discussed that the manufacturer have to provide the density monitor, the gas density monitor, and this gas density monitor will have the potential free contact, right? And it will generate the alarm. To the operator for the refill. And if it is refilled, then it's fine. If it is not refilled, then it will trip the circuit breaker, and circuit breaker will go into the lockout condition. So this also we have discussed yesterday, right? And this metal enclosed housing also we have taken that in the GIS. We discussed yesterday that this metal enclosed housing is not a common enclosure for all. This metal enclosed housing, metal enclosed housing is internally divided, or we can say subdivided into separate gas proof compartment by help of the internally divided by help of the gas barrier, insulators. This what we discussed yesterday, gas barrier insulators, and we discussed that there is two kind of the insulator we use. Two kind of the insulator we use. One is the gas barrier insulator that stop the gas, that do not allow to pass the gas, and one another is the support insulator that allow to pass the gas, but it just support the conductors. It just support the conductors, right? So the housing is internally divided by using the gas barrier insulators. So this gas barrier insulator also visible are indicated by the manufacturer in a different color. Like generally we discuss that we take the orange color, right? This we discuss a study, and we discuss a study about the partition practice as well. The partition practice as well, right? The partition practice as well. Partition practice, isn't it? Partition practice as well. That what is our partition practice? In that, what we discussed that if we are taking a bus bar, so that bus bar would not be common for all. The bus bar we have to divide at each bay level, and up to 220 kV level, the bus isolator also we can also include
Fast acting switch.
the disconnectors and earthing switch also in the bus bar module, right? The bus bar module we can also include, and thereafter, so here this partitions with help of the gas barrier insulators, right? Thereafter there would be separate like after the disconnectors, the next equipment that we are using the circuit breaker. So there would be a separate compartment for the circuit breaker, and thereafter we are using the CT. So there would be separate compartment for the CT, and thereafter we will have the line disconnectors. So for that again we take the separate compartment for the line disconnectors, and if we are using the earthing switch, so that also we can take here the earthing switch as well, right?
Yes, sir.
And then this would be separate compartment. Up to this we can make a separate compartment. And if in case we are using the high line feeder, so we have to use the line earthing switch. So this line earthing switch also will have the separate compartment. And if in case we are using the VT, so VT will have separate compartment, and then it will go to the terminations equipment. We will discuss about the today termination equipment as well, that what kind of the termination equipment we take. So we discussed about yesterday about the partition practice as well of the GIS enclosure, right? This what we have discussed yesterday. Any other thing that we discussed yesterday? Just a quick recap what we have covered yesterday. Let us see this. So what is GIS that we discussed? And then we discussed this is the compact assembly of equipment. We discussed the comparison between AIS and GIS. Then we discussed about the where GIS is preferred. And then we discussed the advantage and disadvantage of the GIS. Then we discussed about the what is VFTU and when it is generated. So it is generated between the disconnectors and the bus bar due to the disconnector operations, because it is very nearly close to the bus bar. So there will be a re-strike occurs between the disconnectors fixed and moving contact, and due to that re-strike, this VFTU generated in the GIS type switchgear substations. So we discussed about sequence of equipment, and then we discuss about the we discuss about the assembly selection as well yesterday. So what is the concept for the assembly selection? What the concept for that? We discussed that till 132 kV means from 66 kilovoltage till 132 kilovoltage, we can take a three-phase enclosure. A three-phase enclosure. We generally take three-phase enclosure means all the equipment will come in a common enclosure. My R phase, Y phase, B phase, it will come in a common enclosure. It will come in a common enclosure. But when the voltage level is increasing, the short circuit current and then short circuit force also it will increase. The losses requirement may also increase. So in that case, when the voltage level and the module will be bulky. So in that case, above 132 kV means from 220 kilo voltage for 400 kilo voltage for 765 kilo voltage. We take the single phase GIS means for R phase one separate module, for Y phase one separate module, for the B phase one separate module, phase wise module, right? This what we discuss yesterday, the phase segregation practice. Then what we discuss yesterday, the phase segregation practice. Yeah, so here it is in when it is coming into three phase, so it is a factory assembled. It is a factory assembled. So it is assembled by the manufacturer. But when we are taking into single phase, then it is to be assembled at the site with help of the flange and bolt connections. So that we have discussed yesterday. Then we discussed that what is the in the enclosure, this enclosure that we are taking, that we are taking, in enclosure, what is the fittings we take, right? The fitting hardware, you can say like that as well. The fittings what we take. So what kind of the fittings we take? What type of the fittings we take? That we discussed yesterday, right? Here is the example of the fittings. So here we discuss about the enclosure. So that we have already taken the aluminum enclosure we take, and then we discuss about the uh, uh, like enclosure. Yeah, that also that already we have discussed about the enclosures, and then we discuss that about the MRE procedure, the enclosure MRE procedure, the maintenance, repair, and extension procedure. That also we have discussed yesterday. And then we discuss about the gas and gas pressures, gas leakage rate, and gas alarm provided by the supplier. And then we discuss about the gas filling point, and then phase segregations. Yes, that we have discussed phase segregations as well. And then we discuss partitions. Yeah, that also we have discussed yesterday, right? After the partitions, we discuss about the yeah module fittings. So in the module fittings, each enclosure, each module we have discussed here that we are taking compartment like here one compartment. This is compartment one, compartment two, compartment three, or module one, module two, module three, module four, module five. Each module each module must have these fittings. So what are the fittings? Insulators, the barren insulators and the support insulators, then density monitor, cabling from density monitor to the LCC panels, then pressure relief device, absorber, and gas filling valve. So this need to be provided in each module. So this is provided by the GIS manufacturer, but as a design engineer, one thing that this provided by the GIS manufacturer, and this information GIS manufacturer will provide in the gas SLD. So this fittings by the supplier, by the supplier and by the supplier, and supplier will provide one gas SLD, gas section SLD, gas section, that how the gas is substance gas is sectionalized or divided. So he will provide one gas section SLD, gas section SLD. So in that they will provide their gas partitions plus the all fittings. So as a design engineer, when you are working on the GIS type substation project, so you have to ask from the GIS manufacturer about the gas SLD, and then you have to review that how the partitions and what kind of the fittings they have provided. This is as per the technical specifications, as per the requirement or not. So as per the requirement, so for the requirement, we have discussed this all practice that also you can take as a reference, right? So here now coming, so this all we have discussed yesterday. Now this is the example of the gas section SLD. So this kind of SLD they will provide. So here I have taken one comment as well. So this is one of my project when I was working for the GIS type substations and doing review of the gas SLD. So what is the comment now? See, this is a 400 kV bus bar scheme, 400 kV substations and 1.5 breaker bus bar scheme. So if you see here, I have taken, this is one, this what indicating, this what indicating, this one,
Bus.
the common bus bar, right?
Yes,
The
sir.
common bus bar they are indicating. Let me take the snapshot. Right. So after this discussion, I hope after the study discussions, I hope that you all are capable that you can ask the drawing and you can review the drawing as well of the gas SLD, right? Isn't it? So this is
Yes,
our conductor, right? The bus bar conductor. And this one is what? This one is enclosure, right?
Indian closures.
This is the enclosure, or we can say aluminum alloy enclosure to be to the point. Then now you see here they are putting the conductors. So now one, what is this black one? What is this black one? This one, this one. What is this? Gas barrier insulator, right?
Yes, sir.
That we discussed a study about the gas barrier insulators, and we discussed that this barrier insulator at each bay level they have to provide. This is the statement I have given. Gas barrier insulator at each bay level. This is what the statement that I have given yesterday. Let me go gas, the partition practice. The bus bar conductor will be part of the each bay module or each bay bus isolators, which means on each bay the gas tight insulator or gas barrier insulator we have to provide or the manufacturer have to provide on the bus bar common module. Taking this statement, now apply the statement into drawing. See, what is the mistake here? They have given one insulator over here, right? And this is our bay one. This is our suppose bay one. Let us our bay one, and this is our bay two, right? This is our bay two. So what is the mistake here by the manufacturer? Here they have provided. See, this conductor going and the next insulator providing here. And what is the concept? At each bay level, it means at this position somewhere they need to provide the insulator, right? Isn't it?
Yes, sir. Yes, sir.
Yes, sir.
Then only I can say that each uh, bus bar will be divided at each bay level. Now, if they not provide is, so this bus bar divided one here and then it coming over here, it would be better if they provide here so that this from here to here, there would be one separate uh, gas section. So here if they need, here if we need to do any kind of the maintenance, so no need to degassing this portion of the bus duct or bus bar. Only here we can, here and here we have insulate gas barrier insulators. So these portions just we need to degassing and we can do the maintenance. So there would be some saving in the subsys gas as well. So the comment that I have given ABB, this was the ABB make GIS. So ABB to incorporate the bus to dia. It is my bus, or it is my dia, right? Or it is my bay. So bus to dia, or you can in simple language you can say bus to bay or bus to feeder, whatever you can say. Gas barrier here, gas barrier insulator over here. Am I clear with how to review this? So now, if you see here, from here, they are taking the bus disconnector and the earthing switch, right? Which is part of the bus bar modules. then one insulator over here. This breaker have CT on both sides. So from here to here one module, here to here one breaker module, from here to here CTA CTB module. Then from here to here again the line disconnectors and their modules, right? And then it is taking out. Then here again we have line disconnectors and earthing switch. So this module here. Then here we have this one is high speed earthing switch, right? High speed earthing switch. And then here it is going outside. Now if you see this much, could you see the BD? This fittings, could you see here? These fittings.
Yes, sir. Yes.
These are the fittings that we discussed now. Gas density monitor, PD, gas filling valve. So this all module fittings in each and every module, because each module is like gas proof. So this module, everywhere they have to provide. So as a designer, you have to ensure that they have provided the correct location for the gas barrier insulator. This is your first review point. Second review point, each portion must have the fittings. Third review point, they will furnish one table. In that table, they will also mention the total quantity of the fittings. So that total quantity should match with your SLD as well.
Sir, also one gas barrier is required at bottom level, no? Where the 89 LE1.
Here,
Yeah,
what is required here?
gas barrier.
See the gas barrier. If you see that here,
This may not be the single module, no?
here
From AB to the front.
from here to here, they have taken one. So it's fine, no need to put it, because from here to here, it is closed loop farming here. Dinesh, they
Okay,
have
but
given
this,
they have
this might
given
be the
answers.
extended. This might be the extended bus bar, no?
No, it's fine. This location is fine.
Fine.
We can go with this one. So the agenda or the outcome of the yesterday 2.5 our discussion is just that when you review the gas SLD, you have the clear concept about that. Now, could anyone tell me what is this? What is this one? What is this?
Expansion connector.
Sorry,
Connector, expansion connector.
this is
Plug.
plug-in connectors, right now.
Bello.
This is plug-in connectors. Plug-in connectors. Could you see this one? Like here, this is our bus bar modules. Connector going through the modules, and here
It's R by V.
means if this is 3-phase, then RYB it is coming, but this is plug-in connectors. I'll take this point as well. So I hope I'm clear with
These
the.
are as per male-female contacts.
This
Which
is
contact?
yeah, plug-in connector for the conductors. Easily, so that easily it can connect from one to another bay.
So to connect the two-way, we use this type of
Yeah,
connector.
this is for the conductor connection. Yes.
Okay.
So am I clear with this drawing? Am I clear with this overall drawing? The gas section SLD. Am I clear with this?
Yes, sir. Clear.
This is what the outcome of the yesterday learning, right? So now we have discussed about the modules. What we discussed about the that is GIS is compact assembly of equipment divided by the gas barrel, and this compact assembly is internally divided by the gas barrier insulators. So we discuss about the gas barrier insulator locations, right? And then partition practice, then three-phase or single-phase enclosure, then fittings. So today let us start with the module, each and every equipment module. Like we are taking here we have the bus bar module. This is our disconnector modules. Here CT module, breaker modules, CT module again, disconnector modules, earthing switch module. So let us discuss about each and every equipment module, how it looks like at the site, and their like concept as well. So let us start first with the bus bar modules or bus bar compartment. I have one intention or target as well, that sometimes when we visit the substations, we are not able to, or the engineers who are not like familiar with the GIS, they sometimes do mistake in identify the equipment. So I'm keeping this this point as well in the parallel, that when you visit next time the substations, you can easily identify the equipment just by looking the enclosure, and you can easily like identify that which enclosure means which equipment, which enclosure is representing which kind of the equipment. I hope this is clear to all of you, that this enclosure is representing the breaker equipment.
Circuit breaker.
Breaker equipment. This enclosure is representing the CT
CT.
equipment. This orange color marking, what is they representing?
Stop barrier.
This is, yes, gas stop barrier, gas barrier insulators, whatever. Okay, so let us start with the equipment module. Equipment module in GIS. So first, let us start with the common bus bar module. So the bus bar conductor is housed in an aluminum alloy enclosure filled with SF6 gas. As already we have discussed this point, the bus bar conductors may be made of aluminum, or it could be made of copper alloy tubes according to the manufacturer's design philosophy. So it is totally depend on the manufacturer, what is their design philosophy, and the conductor dimension, the bus bar conductor dimension. It will also depend upon the rated current of the common bus bar and the rated short circuit current of the bus bar. So taking these parameters, the manufacturer will decide the dimension, a size of the bus bar conductor. This is point number one. Point number two, the bus bar conductor shall be divided at each bay level, that we just discussed, using the gas barrier insulator. To the barrier insulator, why? Just to avoid damage or fault area in adjacent bay in the event of fault at any bay level. So due to that reason, we are using the insulator. And plug connected from bay to bay. Plug connected, the conductor is plug connected from bay to bay to facilitate future maintenance, repair, replacement or extension easily of the bus bar. And the bus bar conductor shall be provided with silver plated finger contact assembly as well. The OEM needs to provide an extension module or the stop module or end module. The OEM need to provide an end module, and when we are doing the extension in the future, then extension module with an isolating link in last portion of the bus bar for the easy extension in the future. So this like here we can say, like here is one end module, and I think there is one more drawing also in that I have indicated about this end module. Just give me 1 second. There is one more SLD. There's one more SLD in that. Oh, clear. Yeah. Could you see this SLD? Could you see this SLD? What is this? Extension module with isolating link. So when you review the gas SLD, and if there is a probability in the future extension of the substation, then keep in the mind that at the end of the bus bar where the future extension is to be proposed. At that side of the bus bar, take the end module or take the extension module with isolating link. See this drawing, this information coming in the revision one, because initially it was not given by the manufacturer. After comment, they have given this. So when you review, when you review the bus bar module, keep this point also in the mind, right? So here, if you see this one, this is plug connection or removable link. Through that, conductor could be easily connected. Am I clear? With this, please let me know. I'm waiting. Are anyone, Amol, are you there? Amol?
Yes, sir.
Yeah, okay. So now let us see how the bus bar modules looks like in the drawing and at the site as well. So when you are working as a design engineer, you will get the GIS drawing from the GIS manufacturer. So how you will identify that which portion in the GIS drawing is representing the bus bar module. So see here, they have given the plan view and section view. The GIS manufacturer, GIS supplier have submitted this drawing. As a design engineer, you have to review and you have to approve this drawing. So first of all, you should know that how to read the drawing, and you should also know that how to interpret, how to understand about each and every module equipment or equipment module. So generally what we do, if there is any kind of confusion or if any kind of the like for the site practice as well. So when you take that, like when you are taking the drawing, you can also ask manufacturer, GIS manufacturer supplier to do the marking on each model. Like if you see here, I have asked for the marking for the each mod equipment mod marking. So they have marked here. Like this portion indicating the breaker, this portion is indicating the CT, earthing switch, disconnected, high speed earthing switch, disconnectors. So like that, you can also ask your manufacturer to do the marking as well. Why I'm telling this point? Because as a design engineer, you might aware about the equipment, but when you are sending this drawing at the site for the construction purpose, and if in case you are taking the modular type GIS, in that we have each, and for each equipment we have separate module. In that case, this module with help of the crane to be bolted or to be connected at the site. So if you have given the clear equipment module, so that would be easy for the site engineer also for the assembly of the module, right? So due to that reason, I'm telling this point. Now, so as a design engineer, if they're submitting the drawing, so how you will review? So they will submit, the manufacturer will submit two view, the plan view and the section view. Plan view means how this equipment looking from the top. So this is the, now if you see, this is, we are taking the single phase enclosure, right? So R phase, Y phase, B phase, three phase, right? So this module, this type of that this type of the module representing the common bus bar. This is the top view. Now, just for your easy understanding, I have taken one another site photo. Unfortunately, I could not get the same site photo because this drawing is under review. This project is under drawing designing stage. So there was another project which is installed at the site. So I took that site photo. So could you see here? This all is representing the from here
It
till
is.
here. This all representing the common bus bar. So if you see this bus bar from the top, if you see this bus bar on the top, it will appear something like this, right? Please, like, if you're getting the point, let me know, because then I can speed up my discussion.
Yes.
Yes, sir.
Second,
Yes, sir.
now they will submit two view, the plan view and the side view. Now you are standing here. That suppose you are standing here, standing here, standing here, standing here, and now you are looking this model from the side. You are looking this model. So how this model will look like? This model, how will it look like? It will just appear as a circle, just right from this view, just a circle, isn't it?
Yes.
Right? Just a circle. So
Yes.
in this section, it is how appearing just as a circle. Now in this circle, if you see, there is a small bolting here. This is small bolting also they have indicated here, right?
Yes, sir.
Right? Bolting is also indicated here. But it's just a circle. So this is bus 1, like here, main bus 1 and main bus 2 is double bus bar scheme. Now, so it is representing the main bus bar. Now, if you see, could you see this one? Could you see this one? Could you see this one? Unfortunately, this view is not clear from, it is not placed here, but you have to make some imagination
Mechanism
now.
box, sir.
Imagination now. So what is this? What is this?
Mechanism box.
Now, see, there is a difference in both the drawing. In this drawing and in this drawing, what is the difference? Could anyone identify the difference? See, in this drawing,
Mechanism box is a mirror.
the disconnector, this equipment is isolator or disconnector, whatever you can say. Okay, this equipment is isolator. So this isolator is coming side by side. Side by side, right? Side by side. This one, again isolator or disconnector, whatever. Isolator. It is coming side by side. So the bus bar running through, and on the outer side, this connector we have taken, which is good practice, because when you require any kind of the maintenance, you can easily access the disconnector. But here, if you require any kind of the maintenance, then on the disconnector, so the access is not as easy as here. So here they have taken the disconnectors, which is on the this side, this bus bar here, and in this it is good, it is the disconnector, it is on the outside, side by side. So this module, this kind of equipment, this equipment is representing the disconnectors, and we will come on later on about the disconnector. But first of all, I hope the bus bar is clear. The bus bar, the plan view, side view, and the side photo, it is clear, right? First, tell me about the bus bar module. Am I clear with this, and this? Correct?
Yes, sir.
Yes.
Second point, and what we discuss in the bus bar also, we discussed that in the bus bar module, the bus bar GIS module, what we discuss, that we take the end module
And extra.
in the last of the conductor or last of the bus bar, or we can take the extension modules with an isolating link, extension module with an isolating link for the future extension, plus one more point we can also add into the busbar module. One more point. This point is spacer. Spacer are the buffer module. Buffer module. Buffer module. Spacer module. This is also we take. And let me add one more point. We take one more module. Bellow. This is not the model, but we take the bellow. Bellow is allowed when the current flowing in the conductors, and when the current is due to the heat, when the current the busbar conductor is expanding. So this bellow allow the conductor adjustment at that moment. So this is provided by the manufacturer again for the conductor movement, and this spacer or buffer module also provided in the busbar module by the manufacturer as well. Let us talk about the buffer or spacer compartment. And this buffer spacer compartment is very much utilized for the service continuity. This buffer compartment is provided for the service continuity as well. We discussed yesterday about the MRE procedure. So this buffer compartment is part of the MRE procedure, or it is part of the service continuity procedure. So where the layout consists of two or more bays coupled to each other via the bus bar. The bus bar shall incorporate an additional buffer or spacer compartment to allow the maintenance person to move between the bays to carry out maintenance activity. The buffer or spacer compartment shall be suitably sized such that a minimum 600 mm width spacing is provided between bays to allow access and movement of person to carry out the operations, regular inspection, and maintenance tasks in the module. So this is the concept, how this concept comes into the drawing. So here we have the drawing for that. So if you see bay 1, bay 2, bay 3, here we have the common bus bar. So if you see this, could you see the yellow mark? Could you see the yellow mark?
Yes, sir.
This yellow mark is for what? This is our buffer module. Buffer, our spacer module. Why it is required? To allow the easy access and movement between the module for operations, for regular inspections and maintenance activity, right? And this is also important when the degassing we are doing. Suppose if you see here in this particular, here there is two locations buffer we have taken. One in the common bus bar, in that locations buffer we have taken, plus buffer taken between the disconnectors and the breaker module as well. Here we have the breaker module and here we have the disconnector module. So in order for the maintenance purpose, between the disconnectors and breaker buffer module given here. So why buffer module we have given here? So when we require any kind of the maintenance on the breaker, no need to touch the bus bar and disconnectors module, right? This buffer module, if we require to reduce the pressure, so we just need to reduce the pressure 50% of the buffer module only, right? My bus bar disconnector is healthy and we have not touched this. So this buffer model provide this kind of the provision, plus it provide the space so that easy access between each modules, between each bay could be achieved. I hope I'm clear why the buffer model we take. Am I clear?
Raghav sir,
Yeah.
sir, this buffer module is a live part or it is?
Live part. It is live. It is a live part. It is just say module in that equipment is not this, but conductor is running through.
Okay.
Yeah. Now, for the bellow model, could you see this one? Could you see this one?
Yes.
If you can see, then see yes. If you cannot see, then so no. At least I will not wait for the
Yes,
response.
sir.
This is what?
Bellow.
Yeah. This is bellow. It allowed the conductor movement.
Okay, sir.
It will allow the conductor movement. Yeah. So this is all about the bus bar model.
Hello.
Yeah, yeah.
Sir, length of the buffer zone is we can easily move that. I mean, we can easily adjust that.
Yes, yes. Yes. Yeah. For that reason only, it is provided by the manufacturer.
Okay, sir.
Okay. I have marked here because when you see sometimes the model drawing and you cannot see that which equipment here. So if you are getting confused, so do not confuse. This is not equipment. This is just a spacers, buffers. Now coming to the next equipment module. So after the bus bar, let us take about the breaker module. So how the breaker module looks like in the drawing and at the site photo as well, just for the comparison purpose. So the breaker, so we discussed about the bus bar conductor sizing, that it will be materials and size, right, provided by the manufacturer. Now coming to the next equipment, which is breaker equipment. So this breaker equipment module, so breaker shall comply with this IC 62271-100, same as in the AIS. So breaker is not going to change whether you are working in AIS or you are working with GIS. Standard will be the same IEC, the same as AIS, and the rating shall be as per the project technical specifications. Each breaker shall have a spring drive mechanism box ensuring proper closing and opening of the breaker contact. The breaker layout arrangement shall be vertical or the horizontal. It could be vertical or it could be horizontal. Generally, for 66 kV, 110 kV, 132 kV, we can go with the vertical kind of the arrangement. But for the 220 kV, 400 kV, 765 kV, we go with the horizontal arrangement. In this particular site photo, the breaker is horizontal arrangement, but needs to provide higher mechanical stability and ease of the maintenance. The breaker shall be operated by a motor that charges the spring stored energy, which is charged by the spring and stored energy. So let us see how this breaker module looks like. So it is the site photo. Here we have the breaker, and this is the snapshot of the GIS drawing. So how they indicate the breaker in their drawing. So this equipment, this portion of the drawing, it is representing the breaker. It here this one. If you take this one, so this one from here to here, from here to here, this one, and this one. This is your operating mechanism. So this one operating mechanism, this is site view, how it looks at the site, but same how it looks in the drawing. So it is appearing like this. So this is the breaker module in the drawing, and this is at the site how it looks like. Let us take the next equipment model, how it looks like. So taking the bus bar disconnectors and the maintenance grounding switch. So the GIS disconnectors and grounding switch shall comply with the IEC 62271-102, same as in the AIS, not going to change anything. But just the indoor installation is indoor, that's the only change. So disconnect switch or isolator shall be gang operated and separated phase-wise for 400 kV into 20 kV, and as we already discussed that we take single phase arrangement for 400 and 220 kV and three-phase type for 132 kilovoltage and below. It shall be group operated with one common motor operated mechanism for all three phase. The disconnecting switch and earthing switch shall be provided with window to inspect switch contact positioning directly, whether the contact is open or closed. So you can see this in this view. It is here indicated that you can see through that whether the contact is open or closed. So like through that you can see that this is the disconnectors and here we have the earthing switch. So this earthing switch open or closed. This disconnect is open or closed. This through the inspection window we can also easily check that. And how the this bus bar disconnectors looks like, how is their view. So this photo is representing the bus bar disconnectors. So here we have the bus bar. This module this is indicating or representing the bus bar disconnectors. How it looks at that in the drawing. So this views is clear. I hope the bus, I think we have taken the bus bar. So this is, yeah, disconnectors. So now this portion, this, and this, it is representing the isolators or disconnectors. Now, to operate this disconnectors, we have this operating box. Could you see this operating box here? Could you see this operating box? Operating this at the site, but in the drawing, how it looks like? This is the view in the drawing. This one, this rectangle. Could you see this? This is here. Could you see this
Yes, sir.
here in the back side? Could you see?
Yes,
here?
sir.
This is indicating the disconnectors operating mechanism box. Here we have the disconnectors rod. Could you see this rod? Yeah, they are operating the disconnectors. Here in the front view, side view, here we have the disconnectors. So disconnector will generally or preferably it is good to take side by side arrangement to the bus bar. So this representing the disconnectors. And this portion, it is representing the earthing switch, the bus bar earthing switch that we take between two disconnectors. On the top of the models here, we are taking the maintenance earthing switch. Maintenance earthing switch. So here we have the disconnectors model. So now in the disconnectors model, we have two kind of the arrangement. With the disconnectors and earthing switch, we have two kind of the arrangement. So up to 132 kilovoltage level, the design of combined disconnectors and earthing switch allow for a reduction in space and the reduction in cost as well. But we have to check with each manufacturer that whether they have at that particular voltage and that you are working the project at that voltage level, whether the manufacturer from where you are taking the GIS, whether they have this combined assembly or not. So we need to check with the manufacturer as well for their availability. So due to that reason I'm putting this statement here, because it is not possible that each and every manufacturer have this arrangement. Generally, most of the manufacturer have, but we need to check from the manufacturer as well. Generally, up to 132 kV, we take this combined arrangement. Up to 132 kV, design of the combined disconnectors and earthing switch allows for a reduction in, and why we take that arrangement? Just to reduction in the space and reduction in the overall cost also it provides. It means we take a 3-position disconnector switch. So there are 3 positions. If you see here, so this is the statement, how this statement converted into the drawing. Here we have the drawing. So if you see here bus bar A, so from the bus bar, we are taking this disconnector here. So now this disconnector is combining the earthing switch here module in one, right?
Yes.
So it means if you see in this drawing, in this particular drawing, it is separate arrangement right now. Separate arrangement here.
Yes, sir.
It
Yes.
is separate arrangement. Separate arrangement. So I'm telling that this arrangement, no need to take separate arrangement. This earthing switch could be combined with the DS and then it will be converted as 3 PDS, 3 position disconnector switch. And what is the 3 PDS? What is the 3 positions? Positions 1, disconnector open, earthing switch open. Means this position. In this position, if you see, my disconnector is open, earthing switch open. No any operations. Each open positions. Disconnectors close. So I'm closing the disconnector. So when I'm closing the disconnector, then earthing switch will be open. Earthing switch open and disconnector open, earthing switch close. So now this moving contact we can close with these positions. It means now disconnector open but earthing switch close, which is are 3 positions which are used until are up to 132 kilovoltage. So a common motor drives the combined disconnectors and earthing switch, which is interlocked to allow safe operation. So easily mechanically interlocking also possible here. So this kind of arrangement is more safer because the mechanical interlocking is directly possible here. In this arrangement, since both disconnectors and earthing switch is in separate module, so mechanical interlock may be difficult. Only electrical interlock would be possible here. But here, if we go this kind of the 3 PDS arrangement, so mechanical and electrical both interlocking is possible. So here bus bar compartment both interlocking is possible here. So disconnectors and earthing switch shall be separate models. So for higher voltage level, we go with separate models. The disconnectors shall have a minimum 8N over 8NC contact for their signaling purpose. So here, if in case we are taking a 3PDS arrangement, so the SLD will be accordingly to that arrangement now. So when you prepare the SLD, make sure what arrangement you are taking. If you are taking the 3PDS arrangement for the disconnectors and earthing switch, in that case, your SLD will look like this. This is combined arrangement. So when you prepare the SLD with this view, with this arrangement, right? Is it making sense? And if in case you are taking both in separate module, then prepare SLD with this kind of arrangement. This is our isolator module. This is our earthing switch module. So at the time of the SLD preparations, this also we have to like indicate that what kind of the disconnectors earthing switch we are taking. Particularly in the GIS SLD, the SLD which is submitted by the SLD which is submitted by the GIS manufacturer. In that SLD, it should be clearly indicated because GIS manufacturer going to provide the GIS module, so they will take a call that which kind of arrangement they are going to propose. Yeah, that's fine. Disconnectors and earthing switch is together. Yeah, that's fine. It could be together with high voltage level as well, and it is good because the interlocking is easily possible. So that's what I'm telling, that you check with the manufacturer that if they have the arrangement with the combined arrangement, then it's good. You can take that arrangement. Okay, Santosh. Yeah. The same region put by the OEM. Yeah, yes, the same region. Okay. I hope it is making the sense. Now, how this 3PDS looks like internally. So it is an internal view. Like here we have the barrier, gas barrier. So now see how the equipment changing now. How the equipment is changing now. This is your disconnectors in the GIS, right? In AIS, how your disconnector looks like. It is your disconnector in the AIS, right? Too much compact. So disconnector here, this is soft for the movement purpose. Here, earthing switch. Here we have the bus bar. With the help of the soft and drive mechanism, we move this arrangement inside the module. So implementing the function of disconnectors and earthing switch in one enclosure makes it compact, and the disconnectors earthing switch interlock is made automatically. So this is the advantage taking both combined type disconnectors and earthing switch module. Now coming to the insulating link. What I mean by the insulating link, when you see the drawing, this is a GIS SLD, GIS substation single line diagram. So if you notice here, there is a difference in the GIS SLD and the AIS SLD. Could you notice this yellow highlighted portion? This yellow highlighted?
Yes, sir.
This
This
yellow highlighted. What is this?
a link between connect to the earthing.
It is the insulating link, which is 10 kilovoltage rated. Whether it is required or not required, please, when you prepare the SLD, make sure that each and every maintenance earth switch have this kind of the facility. Please indicate this in the SLD as well, because I have seen so many SLD, the engineers is preparing the SLD for the GIS subsystems, and they do not indicate this insulating link. They just prepared SLD without link, directly grounded. Do not represent direct grounded earthing switch. In the grounding, there must be a insulating link. This is important for the testing purpose. So this is the insulating link that need to be indicated in the single line diagram. Why we are taking that insulating link?
So what are these three lines also?
RYB phase.
Oh, okay.
Yeah. So an insulating link is required at the time of testing, particularly for the voltage and current injection testing of the internal part of the GIS. An insulating link allows the testing to be done without removing gas or opening the enclosure. So through this insulating link, we can do directly internal test. A typical test would involve under the GIS testing is the measurement of the contact resistance of the breaker, that how much the resistance between the breaker. So for that, we need to do the test using two ground switches on both sides of the circuit breaker. So close the both side of the ground switch, and then we do the counter resistance testing of the breaker. So this test is achieved by this insulating link. To inject the voltage at the time of testing, an insulating link is required on the GIS enclosure, right? So this, when you prepare the drawing, please indicate the insulating link with your earthing switch as well. So this test is performed. This test is performed on all maintenance earthing switches in open conditions through 10 kilovoltage injection for 1 minute, and this is 10 kV test on the GIS substation. This is also one test. So this 10 kV test is performed on all earthing switch, maintenance earthing switch in open conditions through 10 kV injection for 1 minute. And the purpose of this test is to ensure the quality of earth switch isolation and to ensure the absence of any leakage current, and the breaker contact resistance testing also can be tested with help of this 10 kV test. For this test, the earth switch insulating link shall be designed for 10 kilovoltage insulating level. To conclude, all earthing switch shall be insulated from the enclosure and connected to the enclosure by a removable link to facilitate the current and voltage injection test in the GIS module. So due to that reason, we provide the insulating link with the earthing switch, and when we prepare the SLD, make sure it is given. Now coming to the earthing switch, and why we take the earthing switch and type of the earthing switch. So there are two type of the earthing switch used in the GIS type substations. One, in case of the AIS, we take single one type of the earthing switch, which is the maintenance earthing switch. But when it comes to the GIS, we take two type of the earthing switch in the GIS substations. One designed to operate on no load condition, no load conditions, and that called as maintenance earthing switch. And second earthing switch is fast acting earthing switch, or sometimes we call as high speed earthing switch, that can operate on short circuit condition as well. That is why they are called as make proof earthing switch. Short circuit conditions, if required, and can also be used as a maintenance earthing switch whenever required at maintenance. So if you see this, I have taken one extract of the GIS SLD. In that, if you see the disconnectors here, we have separate model for the earthing switch. But this earthing switch must have the insulating link here, right? Insulating link here. Then breaker CT, then disconnectors with two earthing switch, one breaker side. So there should be one insulating link over here as well. And then outgoing line, and then S is representing the high speed earthing switch, speed earthing switch. And then this one. So here we have maintenance. M is representing this, all is this one is, these are the maintenance earthing switch. This one maintenance earthing switch, which is motor operated, and this is high speed earthing switch, which is spring charged operated. So due to the spring operations, this is fast compared to the motor operated. The earthing switch shall have flexible copper conductors with a minimum diameter 50 millimeter, connecting the earth switch to the ground. Earth switch connections to the ground shall be rated for fault current and provided with a silver plated terminal connector as well. The earthing switch we take generally 606 and see normally auxiliary contacts. So now I hope the maintenance earthing switch why we take this point is clear to all of you, that we have discussed in the AIS module number 4. So now coming to the high speed earthing switch, that why we take the high speed earthing switch in GIS and why we do not take high speed earthing switch in the AIS. So the high speed earthing switch are capable of closing any live circuit conductor twice without damage to earth switch model and without damage to any GIS enclosure part. This is the feature or facility of the high speed earthing switch. In GIS, the equipment is enclosed. Now coming to why we take the high speed earthing switch. So in the GIS equipment, all the disconnectors, breaker, CTVT, all equipment is enclosed in metal enclosure that cannot be seen physically every time from outside. Therefore, the high-speed earthing switch is used for the safe earthing of circuits, even if the voltage is present. Even if the voltage is present, and if the circuit to be earthed was accidentally could not isolated from the live section by mistake. So further, this high-speed earthing switch has a stored energy spring mechanism to provide a high-speed closing. The spring which store the required switching energy can be recharged with help of the motor or manually also in the case of emergency. Let us take few more detail about the high-speed earthing switch and where it is required and when it is where it is not required. So the installations location of the high-speed earthing switch, the fast acting earthing switch will be used in line bay at the entrance and exit location of the transmission line. It means it should be in the line bay only, not in the transformer bay, not in the reactor bay, only in the line bay only. To dissipate the inductive and capacitive current from parallel cables or parallel overhead lines to the ground, and thus reduce the risk on the GIS enclosure. What I mean to say in other words, Means let us take a substations here. Let us take a substation here, and then the transmission line going to another substation. Now, so this is our could be any sending substation, or it is a receiving substations. Now this equipment, all the equipment is now the major equipment, the switching equipment is enclosed in, is placed in a metal enclosure and filled with the SF6 gas. Now when we need to, suppose that fault happened in this transmission line, and we need to take this line under maintenance. Under maintenance. So what we do? We open the breaker to the sending end, right? We open the breaker, and we also open the breaker to the receiving end, and then we open the disconnectors, then close the earthing switch and close the earthing switch. Now here it is important here. So when we are closing the earthing switch, what will happen? This transmission line have the, suppose it is having a nearby another transmission line. So between two line, what would be? Capacitive coupling, right? Capacitive coupling. Please let me know if I'm clear. And there would be inductive effect as well, inductive coupling as well. So it means even though this line breaker is open, line is isolated, but the charge will be exist on this conductor. So when you are going for the maintenance, then you are closing the earthing switch, right? You are closing the earthing switch. Here space not available, so I'm taking outside. So what will happen when your moving contact approaching to your fixed contact? What will happen? Your contact have the charge. Because your contact is connected directly to the conductors. So there might be a small arcing. Is it making sense? Small arcing is that making sense? It is grounded.
Yeah.
This portion is grounded.
Yes,
This
sir.
portion has the charge. This portion is charged.
Yes,
This
sir.
portion is grounded. So what will happen? If the small arcing happen, this arcing will be inside the GIS, inside the
Yes, sir.
gas. So what will happen? Your gas insulating property weak, right? Because arcing, if the arcing is happening inside the gas, so there would be decomposition in the gas, right? So due to that, the byproduct will come of the gas, and it may reduce the insulating property as well. It may weak the insulating property as well. So what we want when we are closing this line earthing switch, we want a very fast closing, very quick closing, very high speed closing, so that the arcing we can reduce time. If closing is fast, so arcing we can reduce, right? Now your contact will quickly created, right?
Yes, sir.
So due to this reason, in GIS, in every line bay, we have to take the high-speed earthing switch. Otherwise, if we do not take high-speed earthing switch, these operations you are taking with the motor have some inertia. Motor take time to get the speed. So we do not take motor. We have to take the spring. We do not have inertia, which operation is faster compared to motor. So every line bay must have a fast acting earthing switch which is operated by the spring. So due to this reason, we indicate as also sometimes. Am I clear that why we take the high-speed earthing switch on the GIS? And when it comes to the AIS, so you know in the AIS, there is no any insulating gas present. We are not taking any kind of the gas. So there is no, if this arcing not going to weak the insulating property of the surrounding air. So just we take the capability of the contact of the earthing switch, that this earthing switch contact must be capable that they can carry the induced current. Right? Am I making the sense? Why we take the high-speed earthing switch in the GIS and why we do not take the earthing switch in the AIS? So during the earth switch, and since the fast acting earthing switch will be used in the line way to dissipate the inductive and capacitive current from the parallel cables or the line to the ground and thus reduce the risk on the GIS enclosure. During the earth switch closing operations at earthing switch contact fixed and moving approach each other, a point is reached where the gap between the contact equal to the minimum flashover distance and therefore an electric arc is initiated in the enclosure, GIS enclosure. Under the influence of an arc, if moisture is present, the asepsis gas is distressed and secondary decomposition produce such as highly corrosive hydrogen fluoride, highly toxic gases start to form, and these decline, they are weak the insulating property of the gas and may cause rapid corrosion in high voltage switchgear as well. So to avoid these situations in GIS substations, we take high speed type earthing switch in GIS. In AIS, we not have any metal enclosed gas and we do not have any subsist gas housing, so no any chance of decomposition. Due to that, high speed earthing switch not required in AIS type substations. So, in addition to above high-speed earthing switch can close or make an earth connection safely even if the feeder has not been de-energized from the other end, so that the fast-acting grounding switch is better able to handle discharge of trapped charge to ground and shall be provided with flexible copper conductors of 50 square mm to earth with the common grounding systems. Transformer bay do not have such a long overhead transmission line. Reactor bay do not have such a long transmission line, so the trap charge will be very less. So in those kind of the transmit bays, no need to consider the fast acting earthing switch. Am I clear with the fast acting earthing switch, high speed earthing switch, why we take?
Yes, sir.
Clear, sir. But sir, like one operation will be understood, sir. Whenever the system faulted, then after how to sequential operate, the breaker will be off. Then after our switch, high speed earth switch is connected and
Same as we have discussed in the AIS, the same switching sequence here.
okay, means high speed earthing switch has to operate automatically, no, sir?
No, it will not.
They
operate.
command
Same as we
okay.
discussed in the AIS herself.
Means
Continue
AI
the
is
same concept.
in sir, but AI is in the operate by the manually and but in the GIS.
Harshil, let me take one more time.
Okay, no
Same as
issue,
we
sir.
have discussed
After
in
our discussion.
AIS.
Okay, okay, sir.
Same as we have discussed in AIS, the switching operations, same in the GIS. Only the type of earthing switch is changing. Just we are taking high-speed earthing switch. But switching sequence, switching philosophy would be the same.
Okay, sir.
Whatever you have discussed, we have discussed in the AIS, apply the same concept in the GIS.
Okay, sir.
Sir, HES is manual or automatic type earthing switch?
What is automatic and what is manual? Yeah.
Manual means as the AIS, you have to close the earthing switch by
Yes,
manually.
same in the GIS. We have to close that. We have to open the breaker, right? We have to open the disconnectors. And once the disconnector is open, then we have to close the earthing switch. Now this earthing switch or equipment closing you can do locally or you can do by remote by using the VCU and SCADA. Okay.
Sir, it is written here, capable of closing any live circuit conductor twice.
Yes.
So, twice means like,
Twice means two.
no, twice means two, but it in their lifetime.
Means it have such insulating property that that even though since actually the equipment is enclosed in a metal housing, so you could not like suppose you could not or you are not sure that whether the disconnectors is physically isolated or not isolated, right? That
Yes, sir.
that you cannot see every time.
See.
And ideally the earthing switch should be closed when your isolator is open, right? So
Yes, sir.
in that case, accidentally if you are closing the earthing switch, so this earthing switch module is capable that they can, when you are closing, then what will happen? The short circuit will create, line to
Yes, sir.
ground point happen, no?
Mm-hmm.
So this earthing switch module is designed with this facility that they are capable to closing any live circuit 2 times in their life as well.
In their life, okay.
Yeah,
That's what I-
without damaging.
Okay, okay.
And due to this reason, it is called as make-proof earthing switch. Make-proof earthing switch.
Okay, sir.
Yeah. Coming to the next equipment, the next model, which is the next equipment model, which is the CT model. So first of all, how the CT models looks like. So here we have, this is the like GA drawing of the CT. The CT, how it looks like, but at the side CT, it will look like this. CT here, CT here. It is the plan view, and it is the side view of the CT, but CT will look like here at the side like this. And inside the CT, we do the core assembly, CT core assembly, like 1, 2, 3, 4. How much core required, that assembly we do inside the here. And due to that, it is looking, most of the time it looks in the circular shape, So the CT cell bearing type multi-ratio, multi-core, same as we have discussed in the AIS, with fully distributed secondary winding and multi-core type as per the 61869 part number 2, same as we have discussed in the AIS. And the CT is mounted inside the high voltage enclosure. The secondary terminus of the CT cell will be placed outside the high voltage enclosure. So if you see here, could you see this portion? Could you see this portion here in the drawing? Could you see this portion here? Could you see my mouse, my cursor here? This is our secondary terminus. The secondary terminus of CT cell will place outside the high voltage enclosure and mounted in suitable accessible terminal boxes. The secondary leads of all the CT cell will be wired to terminals. It will be possible to test each CT without removing gas through the insulating grounded switch that we have discussed, the insulating link. The rating number of course ratio across class characteristics for the individual CT secondary course shall be as per the project technical specifications. So according that we have to take the CT rating. Right now, coming to the 2 CT in the GIS. Why we take the 2 CT in the GIS? So I have taken a SLD snapshot. If you see here, we have double main bus bar scheme, then disconnectors. What is this? Earthing switch. What is this? I hope now this is clear so far to all of you, right? This what is
Yes, sir.
what is H?
High speed.
High speed earthing switch. See, there is one mistake in the drawing. Not the mistake, but one like I'll take this point later on. take this point later once. Okay. Yeah. See, I just want to tell one like a recommendation for the disconnectors, disconnector representation. Could you see this disconnector here? It is representing like this. So what is this? And what is this?
Fixed contact and moving contacts.
Yeah, this is your,
Moving contacts.
and this is your.
Fixed contact.
This is
Motor.
not the GIS SLD, GIS manufacturer SLD. This is prepared by the EPC company design engineer. EPC company design engineer, this SLD is prepared. So this kind of this character representation coming here. I will recommend to all of you when you prepare the SLD, do not take this connector like this. Do not represent like this. Just make it reverse. Means the you take the fixed contact towards the bus side and the moving contact towards the breaker side.
Okay.
You indicate it over here. Okay.
Okay, sir.
Means I personally don't like this arrangement because the fixed contact we take towards the bus, right? Visa, am I correct?
Yes, sir.
Isn't it? What is your opinion?
Fixed contact.
Which one is correct? This one is correct or this one? Which representation is correct for this isolator? Visa?
The moving part is toward circuit breaker, and
Yeah.
fixed part is toward bus side.
Ideally, moving part should be the potential free, so it can close.
Potential free, na? So means if you are taking here, it will be always
It will be
potential, right? Na?
potential. Yeah.
So potential free. So your moving part should be potential
Free.
free. So it means your moving part should be opposite to the bus bar.
Yes, sir.
Here, your moving is not potential free. Your moving is at 220 kV potential. So moving part take towards the breaker side or potential free. So I'm telling because I have noticed in many EPC company design engineer, they prepare SLD like this arrangement, which is not correct. This arrangement is correct. So make sure when you prepare the SLD, taking this class, after that, do not repeat this kind of the mistake or do not do this kind of the mistake in your SLD. Now coming to the CT. So few company use CT on both side of the breaker. CT here and CT here, both side of the breaker. To cover all GIS compartment or module or equipment under the bus bar protection without any blind zone or dead zone. This arrangement also ensure an instantaneous trip for all faults, instantaneous trip of the breaker, okay, for all faults in GIS and minimize the risk of the GIS gas burn through. Let us take this statement and little bit about the protections we have discussed in the AIS module as well. So what happens, like here we are taking the let us go with a little bit about the protection. So here we have disconnectors. Then breaker, and then CT, and then again disconnectors. And suppose it is the outgoing feeder. Outgoing feeder here we have. Sorry, let me distribute this CT core. Let me distribute the CT core. So generally, let us take any 220 kV. So how many CT core we take? 5 core,
5 core, sir.
3,
5
4,
core.
and 5, right? This core is for the distance protection. This protection
Yes.
model we have not discussed so far. So if anyone who are not getting my point, do not like worry. You just note down the concept. When I will take up the protection module, then you will get this point easily, right? I'm telling this concept just to make you make down. Even though my concept is here, my statement is here, but this statement I'm converting into the SLD. But this SLD with protection, we have not discussed protection. So if anyone not connecting with my statement, no need to worry. Just note down the concept. When the protection model I will take up, then
Metering purpose.
it will be automatically cleared. Multifunction meter. Then here we take the
LBB.
bus bar,
Bus bar backup.
like main 1, main 2. Sorry, this line not from here. Let me delete now.
Yeah, resistor remove.
Let me delete. So when you are making the SLT, make sure that each and every yeah. So CT here, the 3rd core, then 4th core and 5th core. This CT looking towards the bus bar side. So taking this side. So bus bar 1 plus LBB and bus bar 2 here.
Oh.
Like, and the LBB also, local breaker backup. So now it is a outgoing feeder. So what will happen? The fault is happening. So when the fault is happening, first of all, this the distance protection going to trip the breaker, right? Then
Yes.
again, so both distance protection going to give tripping command to the both trip coil of the circuit breaker, right? Suppose my breaker is mechanically stuck, it is failed to operate. Then what will happen? This bus bar protection will operate, the LVB will
Yes.
operate, right? But this LVB will operate
Yes.
after how much delay?
100.
100 millisecond, right? Now
Yes.
after 100 millisecond, it will issue the trip command to the breaker. Now what will happen? Fault happened, arc generated, right? Fault current flowing. What you want? You want as soon as possible the tripping of the breaker, but there is delay of 100 millisecond. If in case breaker could not trip by this. So what we are doing in this arrangement, this kind of the arrangement, taking the distance here, taking the bus bar here, and there would be one blind zone also created. Means if any fault happening from the bus bar till here, so what will happen? This from here, so this fault will come under which protection zone? The bus bar,
LB only bus bar or LBB angle.
yeah, the bus bar protection zone, right? Now,
Yes, sir.
and when the bus bar will operate, when the bus
100
bar will operate,
milliseconds. 100
100
milliseconds after
milliseconds,
delay.
which means fault happening, but your breaker not operating. There is some delay in there. So this is our point one about the breaker, point 2 about the fault happening in this zone. So this zone is, we can say, it is our blind zone. blind zone. Means when this CT will get the current, even though when your breaker closed, right now, if fault happening here, but fault happening here, but you have to close the breaker, then your CT going to sense this current, and then it is issue the trip up onto the breaker. So this portion I am telling as a blind zone, dead zone, blind zone, it is created here. So in GIS, we do not want to take any chance of the blind zone. We want quick isolation of the circuit. So how we are doing this? Now we are taking CT on both sides of the breaker. So on the upper side, CT 3 core that we are taking here, it is for the line distance protection, right? Line distance protection 1, line distance protection 2, it is metering. And on the bottom of the breaker, we are taking the CT, which is responsible for the bus bar protections. So 87, 50 BF breaker failure protections, bus bar protection and bus bar protections too. So now what will happen if any fault happening, you just, once you close the disconnector, if any fault happened here, till the breaker contact here, that now there is no any fault zone. This CT going to sense the current, right?
Yes, sir.
If you are not putting CT, then you are not going to sense the current here unless we are not closing the circuit breaker. So distributing the CT on both sides of the breaker, it is an added advantage. Even though your cost increasing, but you are getting the higher service life. And when your fault happened in the breaker, earlier in this arrangement, breaker was under the bus bar protection zone. But in this protection scheme, if any fault happening in the breaker as well, it will be covered under your line protection. Even though for the breaker, you are tripping the remote side breaker as well, but you are reducing the risk of GIS asepsis gas burn through. Am I clear? The topic of the burn through and why we take the CT on both sides of the breaker in case of GIS. Vishal, this was your continuous doubt, and I have told you that when I will come on the GIS model, then I will take this point. Is it clear to you as well?
Yes, sir, clear.
Okay, so next equipment is the VT. So how the VT looks like. So if you see this,
Hello.
yeah,
This high speed earth switch is not connected to earth. That link in the previous slide.
no. The insulating link is not required in the high-speed earthing switch. You're telling about this link, right?
Yes.
This link is not required in the high-speed earthing switch. Here, na?
Yes.
No. You are going to test the breaker contact. This is your maintenance earthing switch, right? So
Yes.
this insulating link is enough for the 10 kilovolt injection. It is not required here.
Okay, sir.
So now next equipment model is the VT model, how the VT looks like. So the VT, it is,
Burn through is type of arc, no?
yeah, yes.
Okay.
Yeah. So how the VT look like? So if you see this kind of a assembly, this assembly is the VT of the GIS model. How the drawings of the VT look like. So this is the VT drawing, which is given in the GIS module drawing. This kind of the VT. It will appear in the model drawing, but it will appear like this at the site. So the VT is of the induction type. SF6 gas provide the high voltage insulations, and yesterday we discussed with one of the participants about the VT that, and he told that we take the CVT in case of the GIS substations. Please note down, we take the CVT in case of the AIS, and if we require the CVT in case of the GIS, that would be outdoor CVT, not the indoor CVT. So when we take the VT in case of the GIS, that would be EMVT, electromagnetic voltage transformer, not the capacity voltage transformer. And that capacity voltage transformer will come outside of the building, outside of the GIS hall, not the inside. So that is, this VT is your EMVT, simple voltage transformer, not the capacity voltage transformer. That capacity voltage transformer will also come, but that would be outside of your building, the surge, near to the surge arrestor. The surge arrestor, CVT, and wave trap, this and transformer, this 4 equipment is outside equipment of the GIS, not the inside. So this VT is EMVT. So the VT is of the induction type, electromagnetic induction type. SF6 gas provide the high voltage insulations, and the high voltage winding discs are well insulated by the plastic foils. For the AIS, we use the capacity voltage transformer, right? So about the VT ratings and all these things, that would be as per the technical specifications. So now coming to the termination of the GIS. So all equipment that we take, if you see the bus bar, disconnectors, then I think switch, CT, breaker, CT, disconnectors, and then high-speed earthing switch. These all switch gears are, these are equipment comes under the GIS. So these all equipment model we have taken one by one. Now let us discuss about the connection between GIS and the AIS, are the external termination of the GIS. So now if you see here, we are taking a example of the grid. So here we have generations and then transmission line and then entering into the substations. So this line, when it is connecting to the GIS, so the requirement of the terminations. So since the incoming and outgoing of the GIS is outdoor, incoming and outgoing all is outdoor type, it could be outdoor and exposed to air. For example, the overhead transmission and conductors, underground cables, transformers, all those equipment are outdoor. So we need to connect the gas insulated equipment to air insulated medium equipment. So for that purpose, we require the external termination equipment in the GIS substations. Additionally, in GIS type substations, all equipment is not placed in gas insulation. Some equipment is outdoor, for example, transformer, surge arrestor, CVT, wave trap. For economic purpose, so this GIS to outdoor equipment connections will be required. So how we do this terminations? Since the GIS substation is connected to the power system network, there is a chance for impulse voltage or traveling surge voltage to enter into GIS enclosure, which may cause damage to the enclosure. So outside the GIS, we place the surge arrestor equipment for the GIS over voltage protection. Since CVT use a high frequency carrier signals for the carrier communications, so it also placed outside of the GIS. Wave trap are used to trap or stop high frequency carrier signal. Therefore, wave trap also placed outside of the GIS. So in the GIS, the surge arrestor, CVT, wave trap, these 3 equipment and plus the transformer equipment, it will be outside. And so we require the terminations between GIS and the AIS equipment. The connection between the external AIS and the live part of GIS will be made through one of the following piece of equipment according to the requirement, according to the need. So we can take SF6 to air bushing. So this example, if you see this photo here, this one, if you see my cursor here, so this is the SF6 to air bushing. Wall bushings, sometimes we take bushing which is directly installed on the wall of the GIS building. So that also we can take the wall bushing, SF6 to oil bushings for direct connection to the transformer bushings. So we can take this kind of the bushings, the SF6 to oil bushings, SF6 to cable termination chamber. So here, if you see this example, in that we have the cable chamber. So now in this cable chamber, the cable is terminating, right? So let us see what mean by the bushings. A bushings is a device that electrically connect through two different insulating medium. It is connecting the gas to the air, right? So it is a device, or it is an equipment that is electrically connect through two different insulating medium. The type of bushings and their symbols. It is important when you prepare the SLD, you indicate the correct type of the bushing symbol, right? So we need to understand about the bushing symbol as well. So gas to air bushing, if I'm taking a SF6 to air bushings or gas to air bushings, in that case, it like this is a type of the bushing. So it gas to air bushings, it is connecting overhead line plus gas breaker or gas equipment, and this symbol we use for that reason when we are taking connection here. Could you see like here? Could you see this kind of symbol here? This is representing like SF6 gas to air bushings. This one half divided. So this portion is GIS, this portion is GIS, like here. And whatever you are using, you make one legend stable in your SLD and indicate that this symbol representing this kind of the bushings. It's gas to oil bushings. So gas to oil bushing, it is connecting the gas to the transformer. So we generally take this kind of the symbols. Gas to cables, when we require gas to cables, so this generally we take this kind of the arrow to indicate the terminations of equipment. So here we have the gas to air, gas to oil. Now GIB directly terminating on the transformer bushings. And here we have gas to air, a cable. So cable is coming and it is terminating to the cable chamber of the GIS. So let us see some photo of the duct and the substrate to air bushing. So here we have the wave trap, and this equipment is representing the gas to air bushings, and this is representing the gas bus duct. In that bus duct, the SF6 gas is flowing. Right. So how this equipment, this SF6 to air bushings appears in the drawing. So if you see, I have taken another drawing SLD extract. In that we have indicated the duct. So this duct is representing this duct here, this kind of the duct, which is represented in the drawing like this. And now surge arrestor. So here we have this SF6 to air bushing. This is how we indicate into the SLD. And when we prepare the electrical installation drawing, in that electrical installation drawing, this kind of the symbol is represented by this kind of the equipment here, if you see. So here we have the surge arrestor, CVT, and then transmission line coming and connecting to the GIS substations. So here we have the GIS building, here we have the GIS hall, here we have the two floor, the ground floor and the top, first and second, ground floor and the first floor, and we are using the GIS in both floor. Now, in order to terminate the overhead transmission line, which is connecting to the surge arrestor and the CVT, then it is terminating to the gas to air bushing. So one side of the gas to air bushing is connected to the conductor, and the other side of the gas to air bushing is connected through the gas bus duct to the gas insulated switchgears. Am I clear? Am I clear with the terminations? The terminations. Let us see one few more drawing for the terminations. So here we have the GIS module placed inside the GIS hall. Here we have the wall of the GIS building. So in the wall, we have to make opening arrangement. This opening arrangement, this is how we indicate into the drawing, but this is how to be achieved at the site. Here it is a opening arrangement. So this wall, this opening we take generally 1.5 meter long, and this wall we generally take 600 mm width wall. So this wall here, in that the duct opening here, duct coming outside, you can see duct coming outside here, the duct going here, and this duct is connecting to the gas to air bushings. It is at the site, and it is indicated like this into the drawing. Am I clear with with the terminations? With the terminations? With the terminations?
What you are saying, sir? What you are saying that duct is coming outside from the wall. What you are saying that equipment, sir? That red color.
This one?
Yeah. This is this wall. From the wall, the duct is coming here. The person is standing over here. Right side.
Here?
Yeah. The red one.
This is your bus duct.
Why they keep this? Why they keep here the terminated or what? I mean that it is coming outside.
Coming outside. This site is under construction now. You can see the platform. It is under construction. So
Okay.
it is coming outside now. They will join here this stake below here, and then 90-degree, and then they will connect with the other equipment here.
Okay, sir.
Yeah. So when you prepare the drawing, you have to also indicate the depth, the wall opening arrangement. So generally, this kind of arrangement we indicate into the electrical installation drawing for the wall opening. This your drawing, it is how we indicate into the drawing. This is how we achieve at the site, right? If in case we have gas to oil bushing termination, means in few cases where the space is very much limited, in those kind of the project, the GIS is directly terminated or directly connected to the bushing of the transformer. When space is not available, then you do this arrangement. When you have the space, then do not do this arrangement. This arrangement is very much costly. Try to avoid this arrangement if you have a space. But if you don't have the space, this is the only options, then go with this option only. So now here we have the GIS substations, the GIS model placed here, duct coming out, and it is terminating to the gas to oil bushing. This gas to oil bushing is very much costly. So due to that reason, try to avoid this. But if not a space, you don't have the space, then it is the only choice, right? Am I clear? So the supplier shall provide all components of the bus duct assembly, including straight section, elbow, T connection. Section of outdoor bus duct may be installed at ground level or elevated above ground level on the support structure. The supplier shall supply mechanical support structure at suitable interval as required to ensure that adequately supported over the entire length. Additional partitions shall also be provided in long bus duct to limit the quantity of gas in any single compartment in case the maximum amount of gas in any single gas zone shall not exceed 250 kilogram. This is how much generally we fill the gas. If in case we are taking the underground cable, then we take a cable chamber into the GIS and then we terminate the cable to the GIS. Right? Then we have local control cabinet. About the local control cabinets and about the type test, okay, let us discuss this point as well. So in the GIS for each bay, we take the local control cabinet. One local control cabinet shall be supplied for the local control and operation of each bay. Each local control cabinet shall contain the local control, interlocking, operations, and integration devices for the associated GIS bay. And there should be a mimic diagram as well. The LC shall be provided with the following features: a mimic diagram showing the single and diagram positions, indicators, on-off switches for the devices, and local off and remote switching shall be installed and are adjacent to the various symbol of the mimic diagram. So we take the LCC, in that all this same SLD we develop, other GIS supplier will develop on that local control cabinet on the outside, upper side of the door, and each and every equipment operations indications this all to be provided, so that you, by looking towards the LCC, you can see which equipment is closed or in open conditions, and their operations also can be done by the LCC. The following device shall be supplied as a minimum: breaker control switch on or off, indication lamp, breaker local remote selector switch, disconnector switch, control switch on off, indication lamp, ground switch, control switch with on off indicating lamp, mimic bus including symbols according to the single line diagram, monitoring the control of high voltage switching device in a way that digital display of current, voltage, active, reactive power, power factor, etc. So all the big control we do with help of the local control cabinet. Further, this local control cabinet is connected to the control and relay panel, the CRP panels. So all the cables from the LCC will go to the CRP panel, which we installed in a separate control room. And this LCC we installed in the same GIS hall in front of the GIS module. Further, the offered GIS equipment shall conform to the type test as per the IEC 62227 part 203. The manufacturers shall submit type test report for the following type test and additional type tests, if any, as per the 62227-203 are any additional type tests that your manufacturer or client is asking in their technical specifications. So generally this kind of the test we take by the manufacturer, like test to verify the insulation level of equipment, and dielectric test on auxiliary circuits, test to prove the temperature rise of any part of the equipment, and measurement of the resistance of the main circuit, test to prove the ability of main and earthing circuits to carry rated peak, rated short time, withstand current, test to verify making and breaking capacity of including switching devices, test to prove the satisfactory operation of the including switching devices, test to prove the strength of the enclosure, gas tightness test, test on partitions, test to prove the satisfactory operation of the limit temperature, test to assess the effect of arcing due to integral fault, verification of the degree of protection IP class of the enclosure, test to prove performance under thermal cycling and gas tightening test on the insulators test, additional test on auxiliary and control circuits, reactor current switching test if we have using the reactor in the substation. In that case, test to demonstrate the power frequency withstand capability of breaker in open conditions at lockout pressure, electromagnetic capability test, radio interference test if applicable in the technical specifications. These are tests we ask manufacturer to submit for the review as well at the designing stage, at the approving stage. So now, taking all the discussions, let us enter into the GIS SLD preparations, single line diagram preparations. So now the GIS SLD, if we talk about the SLD, so there would be 2 or 3 types of the SLD. The first is key overall SLD, which is similar to the AIS SLD, and responsibility is the EPC company design engineer that who will prepare the overall SLD, taking the GIS and AIS both equipment. Second SLD is the GIS SLD, dedicated to the GIS switchgear scope, and responsibility to prepare this SLD is the GIS manufacturing company. Third is the gas section SLD. Again, it is the responsibility of the GIS manufacturer company. And as a design engineer, you will prepare this SLD and you will provide to the GIS manufacturer. Taking your SLD, GIS manufacturer will prepare this 2 SLD. They will submit to you as a design engineer, and you have to review and approve this SLD. Based on your approval, they will start the production of the GIS, right? So I hope that gas section SLD is clear to all of you. That we have discussed. It would be better if we start SLD in the next class. Is it okay?
Yes, sir.
Yes, sir. Yes, sir. Please next
Yes,
time.
sir.
Class.
Okay. So let
Uh,
us. So in the next class, we will discuss about the GIS SLD and comparison of GIS to AIS SLD as well. What are the difference in GIS SLD and the AIS SLD? What are the difference in that? Okay.
Yes,
Okay,
sir. I have one doubt, sir. You told in the earlier slide the surge arrestor and other devices which are keeping outside. I mean that it is for all application or only some few cases.
No, in the most applications, we try to put GIS outside. If you are the surge arrestor outside, if you are putting surge arrestor inside the GIS enclosure, then your GIS enclosure cost will increase.
Okay. For example, if I use the 132 GIS, in that case, the suggest will be outside or inside the GIS?
See, generally outside, fully,
Okay. Yes, sir.
generally
Yes, sir.
outside, until
Yeah.
unless you don't
Client.
have suppose you don't have the space, you cannot
Okay.
put outside, and you have, in that case, you take inside. But if you are taking inside, then the enclosure insulation coordinations and your insulation GIS enclosure insulation cost will increase. And once the insulation cost increasing, then your GIS cost will also increase. Okay.
Okay.
So
Okay.
try to put the surge arrestor outside of the GIS. In few cases, when the GIS supplier do the insulation coordination study in order to mitigate the VFTO, in those kind of the cases, they put the surge arrestor into GIS, but which is only for the mitigating the over voltage, which is generating due to the transient operations of the switchgear. So for that, they provide additional surge arrestor into the GIS module. But if you are taking for like project where you have the space, you can try to put the surge arrestor outside of the GIS. Santosh, I think in your project you have taken surge arrestor inside the GIS, right?
Uh, Actually, there is one failure in the one substation. Is there any technical problem if you keep the surge inside the GIS panel? Is there any technical failures and technical problems? Technical perspective?
The insulation requirement. This is the only technical.
Because there is no, we did not found the root cause. There is one failure in the substation. When we charge that substation after 24 hours, there will be a fire inside the GIS
Yeah.
panels.
So
So
sometimes
because we find that we assumed that because of surge arrestor it has happened. I mean that what do you say, sir?
So in that project, surge arrestor was inside GIS or outside GIS?
Yeah. It is 66 kV GIS. It is inside the GIS.
The surge arrestor is inside the GIS?
Yeah.
Oh, okay.
Because we checked entire substation, we did not found any root cause. Only so after that, one section of the panels are burned and other section is okay. So after cleaning everything, we charge the remaining section. We keep the surge outside, and the system is running fine. I mean that is why in that case I ask, is there any technical problem if we keep the surge inside the panels?
As I told Puli, generally we keep surge arrestor outside.
Okay.
Puli?
Okay. Yeah, you told me that there is because of some surges it will disturb the inside the panel like that. So you use the sentence. And when the surges occurred, it will disturb the inside the panel. I mean that in that case, that is a technical is not suggestible to keep inside, right?
Keep
Okay,
it outside if you have the space, and if it is additional surge arrestor required due to the system studies, in that case only place it out inside.
Okay, sir. Okay, sir. Thank you.
Raghav sir, I
Yes.
have doubt with the bus duct. It is in a hollow tube or it is running conductor inside that? The first doubt.
It is a hollow enclosure. In that conductor is running, and this conductor is filled with the gas.
It is terminated with the GIS, yes.
Yes.
And we don't have any monitoring device for this because we are using the SF6 gas in GIB.
Now
So
there would be monitoring device on the duct as well.
we have to, and there is any limitation how much meters it can be run? Is anything like that? If our equipment is
Try to keep, because approximately 1 meter cost is around, I'm not sure, but it is around in 4 to 5 lakh Indian rupees. So try to keep it as less as possible to make your subsystem economical. If you are taking higher duct, your cost will jump.
okay, sir.
Yeah.
Thank you.
Okay, any other query regarding the GIS?
Excuse me, sir.
Yeah.
I haven't understood that HSC can be operated twice when live. Meaning of that.
Okay, Chitta, so we can discuss one-to-one separately, okay?
Okay.
Yeah.
Raghav sir,
Yes.
you mentioned the buffer in the GIS. So it is indicated with any color or any specific?
No any color. Not any color. Color for the like gas barrier insulator, only for that we take the color. It is just a extension of the enclosure.
Hello, sir. In the GIS, if you see the bus section and bus riser, some cases we are using the circuit breaker, and some cases only we are using the disconnector in place of circuit breaker. So, is there any, standard procedure or any standard?
Go with
how
the
we are-
breaker. Means you are telling you are not using the breaker in the bay?
No, sir. Because we have a double bus bar. Correct? Okay, we have a double bus bar. Okay, in that case, we are using the bus coupler and bus riser as well. Okay, so some cases they are using that. I mean, that client is saying that use the circuit breaker in all cases. I mean that for the both bus riser as well as the bus coupler. Okay, and in some cases, a client is saying that no need to use the for the bus.
Yeah. So they are telling no need to use the breaker, only go with the disconnector, right?
Yeah. So is there any specific standard or
No any specific IEC standard or type standard. This is project to project requirement.
Sorry, sir.
It is only project to project requirement, client to client requirement. There is no any such IEC standard.
Okay, so that is in general procedure, how we are following without breaker or breaker.
It depends. It depends. Means there is no in general procedures. For the bus coupler, we take with the breaker, but for the bus sectionalizer, it depends what is the required by the client.
Okay. So if you, as far as high voltage is concerned, like 380 kV and 380 kV,
No like that. It is purely
irrespective of the voltage level.
Yeah, irrespective of the voltage.
Okay, sir. Okay.
How they wanted to do the operations maintenance, accordingly they will decide it.
Okay.
I have seen CT also in the bus section, sir. Along with breaker, CT also is there.
Yes. Yeah. Any query regarding the GIS? So no, so we can wind up today.
Yes, sir.
Okay, thank you all. Thank you for attending the sessions. Let us meet next weekend for the SLD and the layout and the earthing practice of the GIS as well. A lot
Okay,
of
sir.
things is pending on the GIS.
Yes, sir.
A lot of things is to be discussed.
Yeah.
Yes.
Yes, sir.
Yeah.
Yes, sir.
Okay, thank you all.
Thank you, sir. Thank you.
Thank you, sir.
Thank you, sir.
Good night.
Good night, sir.